Everyone can hear me fine? My name is Manuvir Das. I work on the Windows Azure team, and I'm here this afternoon to give you a bit of an overview of what Windows Azure is all about. My job on the team is I run what we call the developer experience team. It's one of our engineering teams which builds all the parts of the platform that the developer actually gets to play with, like the SDK, the dev portal where you go and sign up for the service, the service we run in our cloud that does all the management APIs, so you can come in and deploy things in various places. Before I get going, I have to say I did a similar talk at PDC last year, and I was probably a little stressed out because we were just launching the cloud for the first time. So I made the mistake that I forgot to tell people there will be Q&A at the end, and what you do is you come up to one of those microphones back there and ask your questions so they get recorded. So this time around, when I say thank you, please don't all rush out. If you have a question, just go over there to the podium. So before I get going, I do have one question to try to calibrate the audience so I can tailor my talk. Just with a show of hands, how many people in the room are familiar with Windows Azure in some way? Okay, that's great. And how many people have been to the portal or played with the SDK at some point or the other? Not a whole lot. Okay, good. So when I tell you about the SDK today, I remember NBC did this thing a few years ago. They all show reruns during the summer, and NBC used to show the reruns, and they always had this caption that irritated me, which was that if you haven't seen it yet, it's new to you. So I think I'll take some time over the SDK, and hopefully that'll be new to a lot of people in the room. So there's three things I want to achieve in this talk. One is give all of you my take on what Windows Azure is and how you can get your head around it and think about it. And then what's new in Windows Azure, what are we announcing today, what are we making available today in our refresh of the CDP, and how do you actually get your hands on it. So I'm going to start right away with a little demo of a website called tweeval.com, which Steve Marks over here built. And it is running on Windows Azure. And what it is basically is it's a little Twitter-based thing so people can do evaluations of things they're watching or participating in. So this website is running in our production cloud on Windows Azure. And he built it using a thing that he calls Botomatic, which is also running on Windows Azure, which is a way for you to build your own Twitter bots to track various things. So he built a bot for me to do these evaluations. And all of this is running on Windows Azure. So the way we use this thing is I'm going to start it off, and I'm going to use this as an interactive feedback mechanism during this talk. So I'm logged into Twitter. And what you do is basically you send a message to Tweeval. I'm not much of a Twitter person myself, I apologize. But you send this thing to Tweeval, and you need to do two things. One is behind the pound, you need to use a keyword that we can all use for this talk. So I'll just use my name, Das. And then you put in a number between 1 to 10. 10 means this talk is awesome, it rocks. You'll watch it every night before going to bed. And 0 means you hate me. So I'll seed this thing with a 10. And a nice little message. So I'll get that going. So we'll keep coming back. I'll come back later on the talk, and we'll see how things are going and whether you're buying my spiel or not. So just remember, you send the thing to Tweeval, T-W-E-val. You put a pound and put DAS after the pound so it comes to the right bot. And then put a number between 1 to 10. And we'll see how we're doing. Okay? All right. Back here. So what is Windows Azure? I would describe it in just one statement. It's an operating system for the cloud. And I know there's two words in here that are already overloaded, operating system and cloud. So literally, the thing I'm going to try to achieve in the next hour of this talk without actually falling over is leave you with a really good, clear impression of what this statement means, where we're coming from. And really, if that's all I achieve in this talk, I'll be pretty happy. So let's start to dissect the words in that statement. There were two phrases, operating system and cloud. So I'm going to start by defining each of these, right? So what is an operating system? We all use these things every day in two ways, as application developers and as users of an actual PC. So when I think of an operating system, what it means to me as an application developer is, the first thing is, it's an environment. It's an application execution environment where all the hardware and the low-level stuff that's in that computer is abstracted away. So I don't think about things like device drivers when I go build my favorite application. The next thing is, there's a shared file system on the box, and that's just given to me, right? And there's ACLs on files and directories, and I can set them up and take advantage of them. Third thing is, as an application developer, when I build an application and give it out to different people and they run it on their computers, those applications are sharing that computer with many other applications. So there's something in there in the OS that's doing resource allocation from a shared pool of resources. And again, that's not something I really worry about as an application developer. The OS comes built in with support for many different programming models. And as a developer, that gives me the opportunity to use my favorite language and use my favorite development framework that makes me the most agile that I can be, right? And then finally, a good operating system hopefully is interoperable with many other systems, whether they're over the network or different kinds of environments and frameworks, which again frees me up to really develop applications the way I want to develop them, right? So that, to me, is a bullet list of the things that an operating system gives me as an application developer. And if I were to look at it another way, I would say that it buys me really three things. The first thing is that when I write my application, scale, at least to some level within a box, is free. Because there's all these nice abstractions, whether they're thread pools or whatever, your favorite thing. And when you use them, you build your application for, small load or some number of requests or what have you. And as the load goes up or the number of requests you serve go up, you don't really go back and rip everything up to a certain limit, right? So scale is free. The second thing is, all the hardware in the box is not my problem. It's someone else's problem, right? It's just there, and I can take advantage. And the third thing is, when I give my application to somebody to run, what do they do? Or what do I do when I have to run it and test it or what have you? I just type the name of I open my command prompt, I type foo.exe, and I hit enter. And the thing just runs, right? And there's something in the operating system that figures out where to put it, where to run it. There's a loader, all that kind of stuff is built in. So those are the things I think of as an application developer that I just sort of get from an operating system. So going back to that statement, Windows Azure is an operating system for the cloud. So we just spent a minute looking at one phrase, which is operating system. Now let's look at the other one, which is cloud. So what is the cloud? So we have a very simple way of looking at the cloud. It's just a set of connected servers. The key thing about the cloud is more than one. There's more than one server, and they're connected in some fashion. There's routers and load balancers and all these kinds of things that are connecting all these servers together, right? And what you can do on these connected servers as a developer is you can do two things. You can run services, which are applications that run on a set of connected servers. You can put them up there, so you can install them, and then you actually run them. And then everything needs data. So again, on this set of connected servers, you can store some data that your application needs, and you can retrieve it, right? And that's basically a very simple description of how we think about the cloud. And the reason I put up this very simple description was to make just one point, that when we think about the traditional world with a single server or what have you, and we think about the cloud, that is really the fundamental difference. It isn't one machine anymore. It's a set of machines that you want to use in concert to achieve something, right? And that's where all the trickiness comes in. So if we go back to the cloud and we think about what everybody is doing on the cloud today, how do we all build applications on the cloud? The experience we've had on our team, as a company at Microsoft, everywhere, people who've built services, I'm sure many of you in the audience, what do we all face every day in the cloud? Because of this complexity that there's more than one machine. We all pretty much go through the same thing. The first thing is, where are we actually going to run our stuff? We need some servers. Well, fortunately, today we've got to a point where people have data centers, and you can rent space in data centers, so you don't actually go to HP or Dell or somebody and say, hey, give me 10 servers. You can pretty much get access to that through the data center. But then if you go through your life cycle of what you do every day as a developer, the problem you have is that there's two very different things that you do as an application developer or as a team that builds an application, and the line between those two things has blurred. One is, I want to build my application, right? The second is, now I want to run it. I want to make sure it's running every day. And today in the cloud, those two things have been blurred, and we have to think about both those things all the time. So for instance, we have to think about the fact that hardware is failing. Disk drives are failing. There's commodity hardware out there in the cloud. Routers are failing. Switches are going bad. And we want our applications to keep running even when these things happen. So all of us spend time every day dealing with these issues, right? The second thing is, whatever we are building becomes popular, the load goes up, we see more traffic. And when you're out in the cloud and you're running at many servers, what does more traffic mean? It means more servers. So you need to provision more servers in a reliable way. You need to redirect your traffic so it goes to the old servers and the new servers, and that's a non-trivial thing to get done. As your traffic goes up, typically your data requirements are also going to go up. You're going to store more photos and more videos and more metadata about customers. So you need more storage capacity. And again, this storage needs to be reliable and redundant and available and all of that. And you've got to spend time dealing with that issue, right? Once in a while, the service is actually going to fail in some way. And we need a way to actually diagnose these failures and do something about them. And that's going to be complicated when there's more than one machine that's at play. Operating system patches, unfortunately, are a fact of life. And every so often, we have to roll OS upgrades through all these machines that are running our software so we're not vulnerable. And that's its own issue, because how do you do that without taking the service down? New features. The development team occasionally does get time to add new features, and we need to roll them out without disappointing all our customers by taking the service down for some period of time. I mean, the days in the cloud, you no longer get to say, you know, between 2 a.m. and 3 a.m., I have a service window and I'm going to take the service down. Because 2 a.m. on the US West Coast is, you know, 10 a.m. in London, right? And that's not a good time to take something down. So, speaking of London, as your service becomes popular, no matter where you started it, whether you started it in India or the US, as your service becomes more popular, it goes to different locales. And for people, your customers in different locales, you want better latency. You want to run things in that locale. And so you need to expand to new locales, but you want to do it in a very transparent way as far as you, the application developer, is concerned. So that's another thing you have to worry about. And this list goes on and on and on, right? And the point I'm trying to make is that all of us spend large percentages of our TCO or our cycles or our resources on the team worrying about all these issues, which really have very little to do with the unique functionality that we're putting into our service that distinguishes it from all the competitors, which is really where we want to be, right? We want to put in new cool features into our services and roll them out. And that's really the business logic that's unique to our service. The stuff in blue, I chose blue because blue is Azure. And that's where we want to focus our time, right? So another way of taking this whole slide and just making the point all over again is that if you look at those three things I was claiming that an operating system buys you as an application developer, I would argue that in the cloud today, you get none of those, right? Because scale is not free. All of us, as our applications scale up, have to worry about how to re-architect it and rebuild it to scale up to the next level. If you look at every successful service that's been out there, whether it's eBay or you can take any example, the people from those services who've been kind enough to share their experiences in blogs or talks or presentations, pretty much every one of these presentations goes through this timeline. You know, in 2002, we had X number of customers, and this is what our service looked like. In 2003, we reached that level of scale, so we redid everything, and this is what it looked like. And then suddenly we became really popular, and we redid the whole thing again, and this is what it looks like. So scale is not free. The second point I think anybody who's done cloud services would appreciate is, even though you didn't buy the server and put it in there, hardware is your problem. Because all the code you're writing in your service has to be written in a way to deal with this reality that things are failing all the time. Right? And then finally, anybody who's done a serious service at scale knows that bullet 3 is far from where we are, right? Because we all have deployment teams. We have sets of people who do nothing but deploy our services and make sure the deployment worked out. And we deployed to 100 servers, and 10 of them didn't really deploy properly, so I got to go back and fix them up and do something different, right? So I would claim none of these 3 things actually happen in the cloud today. And hopefully by now, I've said enough so many times that the next slide is sort of obvious, which is, why do I think this is? What's missing? There is no operating system for the cloud, right? There is no piece of software running over a set of connected distributed servers that does for me, the application developer, exactly what that one server OS does for a single server. And that's what we think is missing, and that's why we built Windows Azure, to solve this problem for our own services that run on Microsoft today, for services that people outside and all over the web are going off and building. Whether you're the 2 people in the garage building the next Facebook, or you're some big enterprise company and you're trying to move something off premise onto the cloud, these things are not about a particular scenario, right? Everybody building a service at scale that you want to see stay up is going through these problems and needs this operating system that's up in the cloud. Okay, so what is in this cloud OS? The key point, again, is it spans a set of connected servers, and what it has is exactly what you would expect it to have, an abstract execution environment, so you don't care about what are these servers and routers and load balancers out there, a shared file system that is durable, so you can rely on it, resource allocation, you don't care about what else is running on that cloud, you just get to run, and again, you should be free to use the programming model that you wish to use. And furthermore, in the new world of the cloud, there is something that is quite different from the world of the single server. And what that is that really now you have this illusion that you are running in an infinite resource pool, right? A company like Microsoft comes along and builds a cloud and offers it to you, and there are just tens of thousands of machines in this pool of machines that is spread all over the globe, right? Now, clearly, in this world, what you want is you want a model of utility computing, which is that I'm going to use one very small slice of this, right? I know I've got an infinite pool at my beck and call that I can get access to at any time, but at any time I'm using one very small slice of this, and that's all I want to pay for, right? So that's obviously the first model that you pay as you go. The second part of this is it's like electricity now, right? It's coming into my house. I don't care who did what behind the scenes, I just get it, and it should always be there. It should be 24/7. Both the cloud itself should be 24/7, and the cloud should give me facilities. The operating system should give me facilities so that it's really easy for me to build my own 24/7 service, so my customers always see me up in the cloud, right? And then finally, the only way all of this stuff is going to work for a developer is if we've really taken that job of dealing with these servers that are not on my desk, right? They're away somewhere in someone else's cloud. Really simple to manage and to administer, right? So that's really what we're trying to achieve with this cloud OS. So if I now flip my viewpoint a little bit and say, okay, I'm the application developer, let's cut to the chase, the features, right? What are the features I'm really getting that I don't have that let me take advantage of the cloud? The first feature that we think is a key part of our platform is the developer experience. We've put a lot of work into thinking about the whole life cycle of how you go through your development. The first time you build your Hello World, how you test it, you move into testing, into some kind of pre-production environment, then you're ready to launch it live, you do upgrades. So we've spent a lot of time on the developer experience. Can you use all the languages you wanted to use? Can you use the frameworks like Visual Studio and Eclipse that you're used to using? How transparent can we make this thing for you that you just write your applications the way you're used to writing them, but under the covers they're running on this different cloud, right? And I'll spend much more time in the talk covering this aspect. The second aspect is the actual execution environment that your applications are running in. So our data center takes advantage of virtual machines. We use the hypervisor as a way of taking our servers and slicing them into many different slices. This is a way of greatly increasing the utilization in the data center. So obviously that effect gets translated back to the customer. because you're using only a slice of the machine if that's all you need. And all of the hardware comes with this. So one difference between this operating system and the operating system on the single server, if you will, is this is not just software. This is software OS on down, right? We've taken care of all that stack. So all the hardware just comes. The load balancers, the routers, the machines of different kinds, it's all there. It's virtualized, so you run within a VM, but you can also run direct on the box if that's what you need. A key part of what we've done here is we've built a model in such a way that when you write your code, you really don't care that you're in a VM or not, right? You just write your code once the same way regardless. Okay? So that's the second part of what we've done. The third part is service management. So we've built a system. This is actually built into our cloud operating system, so you just get this when you deploy in our cloud. We have a system that automatically manages your service. So when you write your application, you give us some rules about what it means for your service to be up or not, or what your service looks like. Again, I'll describe this in more detail. And then you just give us your code. And the service management system does everything. This gives you the effect of you type the name of your executable and hit enter. That is what the service management system is doing. It deploys your service to the cloud, and then it keeps it going for you. And this is, again, built into our cloud, to our operating system. You don't have to do anything extra to go get this. And then the final part of this is that file system in the cloud. So we have a storage service that runs in our cloud. It's highly scalable. It gives you the illusion of an infinite storage pool that you can just tap into dynamically. And it's highly available. So it's built with a lot of redundancy and fault tolerance in, so that regardless of what is happening in the data center, you always have this cloud storage available to you. And it has a few abstractions that we think are really useful to application developers, like blobs and tables and queues. And I'll touch on this again later on in the talk. And for many of these things, we also have sessions coming later at MIX. And when I cover these slides, I'll give you a pointer to the appropriate session so you can go there and find out a lot more from the people who've built these things. So back to the slide of what is Windows Azure. Now I'm going to expand on this a little bit. I already told you it's an operating system for the cloud, but now I'm going to add a couple of things to this. The first point is it is designed for utility computing. This model of it's up 24/7. It's not something that you're going to go reboot every so often. It's pay as you go. And then if you really want to think in a nutshell, what is this thing doing for you? It gives you a way to write your app, which is what the developer experience is all about, how to host your app, which is the compute part of this, how to manage your app, which is the service management, and how to store your data. And that's the four things really that this operating system in the cloud does. And I think that slide basically summarizes the whole thing. So at this point, I'm going to break off for a little bit and take a few minutes to go through a tour of these four things. And I'll spend a couple of slides on each one, telling you about these different aspects in more detail, and I'll also do a couple of demos for you. So let's start with the developer experience. I think when we set out to do this, we had two things in mind: to make it rich so that it's really easy for you to go build applications, and for it to be familiar. So you don't have to go learn a new programming language or new programming environments or development environments. You should really be able to take the skills that you already have and transfer them over in a very natural way into this cloud, but getting the advantages of the cloud. So the very first thing we did was we built in a complete simulation environment for our cloud that runs right on your desktop. And this is part of the SDK that is available for download, free to anybody, that we ask everybody to pick up. So literally what you can do with this thing is you can build your application, you can deploy it, you can scale it, you can choose as many instances of your front-end servers and your back-end storage and all of that as you want. You can run it, you can debug it, you can test all your concurrency things, and you build your application there. And you can do this on a plane. It's a completely offline environment. And once you're done with that, the SDK itself comes with the tool that packages all your application up for deployment to the cloud. And the big point about this is that the application, as you wrote it on your desktop, is exactly the same application that we're going to run in the cloud. There's no difference. So you don't have to do this twice, right? It's exactly the same bits. So you never get into this thing where, well, I had this set of bits, and I kind of tested in my desktop, and I think it works. Now I'm going to translate this into something else that my IT team is going to deploy to the cloud, and hey, that didn't work, and how do I know what I really changed? It's the same code. It's the same package that goes off to the cloud. So this goes back to the whole life cycle as a developer, right? We're in there as your cloud from step one, right when you run it in the desktop, and then you can go to your testing, pre-production, all of that directly into the cloud. The second part of the experience is support for a variety of languages. When we launched at PDC 08 with our first technical preview, we had support for ASP.NET for front ends, and we also had support for arbitrary pieces of computation that run sort of as a back end, but they had to be in .NET. And today we've opened up the cloud to a lot more. And I've just alluded to it here, but I've got a separate slide on that, so I will come back to that. The third thing as part of the experience is the whole ecosystem of tools and support. So we have an SDK that runs on your desktop. It's completely open. It's got a bunch of command line interfaces to build your package, debug, etc. But we've done a lot of work to integrate it with Visual Studio. And there are add-ons for Visual Studio available where you can create your Windows Azure Cloud project and your templates, and you can hit F5 and debug and build your packages, and you can do all of that. The Visual Studio integration that we've done is entirely based on that open interface. So there is absolutely no requirement that you have to use Visual Studio. In fact, one of the things we did early on was a project to build an Eclipse framework on top of this, right? Just to make that point again, that this is in no way, built in. But obviously, we do think that Visual Studio is a really great environment for developing these apps, and we've tested that a great deal. We do believe that in the cloud, the best way to debug a service that's out there in production is through the heavy use of logging, right? And you use logging for two reasons. One, when something goes wrong, you want to look at your logs to figure out what went wrong. But two, as anybody who's built a service at scale, you'll recognize that the only way you really handle problems without going down is you detect them in advance, right, before they happen. So you look for things that may be going wrong. You look for bad signs, and then you log those things, right? And you look at your logs, whoa, this is getting overloaded, and you do something about it, right? So we've got a whole system for logging built in. We've got a few APIs that you can use from your application to put a log in, and then there's a whole system we've got in the back end that stores all those logs and lets you pull them back out, right? And similarly, we've got a system for alerting. The difference between logs and alerts is logs, you have to go fetch and look at. Alerts, we flag you. You can register a cell phone number, an email account. I don't know if we do any other mechanisms, but you can imagine a few, and that way you get woken up at 3 in the morning, or whoever you want to get woken up gets woken up. Right? And then, as you might imagine, there's all kinds of samples and forums and things that are out there as well. And then the final part of the developer experience that I'll also come back to in a minute with a detailed slide is geolocation. This is a cloud operating system. This is what we've done here is we've built one framework that we think addresses a lot of the problems of application developers. This is not like, hey, let's give you some blobs. Hey, let's give you a service to do something else. It's really a system that was built and designed from the beginning to work in concert. So one of the things we've done is geolocation, and we've done that in sort of a holistic way. And I'll come back to that in a minute. So a little more on, there's a session later this afternoon, actually, I believe in this room. It's the next talk. Steve here will be giving that talk. And he'll go through the developer experience in more detail, and he'll actually go through the process of building your first Hello World app, and he'll open up Visual Studio, presumably, and show you exactly how easy that is. Okay. So time for a demo of this cloud on the desktop. My machine went to sleep. Sorry. Okay, so what I'm going to show you here is I've got an application that is actually a sample that's in the SDK. We call it the thumbnail generator. And before I show you the application running on my desktop, I just want to show you a picture of what the architecture of this service looks like. It's basically a service where you can upload some photographs, and then it produces thumbnails of these images for you. And it's a two-tier service. There's a web role, which is some ASP.NET. It's running behind a load balancer. And in my service, I'm running 2 instances of it. And the web role is basically accepting the photograph and storing it as a blob in the storage system. And then it's putting a request onto a queue saying, produce a thumbnail for it. I've got 3 instances of a worker role that is running in the background. It's some piece of C#, which is basically picking up items from the queue, requests from the queue. Then it's going and finding that photo blob from the blob system. It's running some code to produce a thumbnail and storing that back as a blob. And then the web roles are picking that up again and displaying them on the page. And all of these things are running right on my desktop with exactly the same APIs and all of that that you get from our services actually in the cloud. So this thing is running completely offline, but the bits of this application are exactly the same bits that you would just upload to the cloud and run for real in the cloud. Right? The only thing you change in the cloud is you'd presumably be using the blob store in the queue that's in the cloud. So that place in your config where you're referring to your URL for your blob storage, that's the only thing you would actually change. Okay, so I've got this application running. It's called Photo Gallery. And need to go back there. I've got this application running, and you can see that I've uploaded a few copies of that picture right there. Okay, what I'm going to open up for you now is the simulation environment that we call the development fabric that basically shows you this application running and everything you can do with it. This application is called Thumbnails. And basically, it's showing you a console spew from every one of those instances of your service that's running, the web roles as well as the worker roles. And in this case, I've got 2 web roles, and I've got 3 worker roles. So I can go here and I can see what's going on in any of the web roles, or I can similarly go to any of the worker roles and see what's going on there. And some of the spew you see happening there is the APIs that we have, basically, that we monitor the health of the role. And so you have a callback that you call to say, yes, I'm doing fine at this point, don't bug me. And if you don't say that, then we'll take some corrective actions and restart your role, et cetera. Okay? So what I'm going to do is I'm going to go back to this thing, and I'm going to try to get myself another picture. So I'm going to try to load that. And you'll see another thumbnail showed up there at the end. In fact, let me do one more of these, so we get to the next row. Okay, and if I go back to my development fabric window now, you'll see there's some more spew. I just put in some debugging spew. So in particular, instance number 2 of the web role had some spew saying it got a couple of these requests to add new photos, and then it went back to the worker role. And for instance, if you look at this one, it's got some spew saying it happened to pick up one of these requests of the queue and process it, right? And if I did that several times, there's a complete simulation going on here. So if I hit refresh a few times, the load balancer that we've got simulated in here will actually spread the load, and different instances will pick things up from the queue. Okay. All right. So that was my little demo of the cloud on the desktop. So the next thing I want to do is go back and talk about a couple of these new things that I alluded to on the previous slide. So the first thing that's new in the refresh that we're doing for you today is what we call full trust. So those of you who have played with the previous CTP will have noticed we had a restriction that your applications had to be managed code, ASP.NET or .NET, and they had to run in medium trust, which is more like a shared hosting model. Well, we've taken that restriction away as of today, so your applications can run in what is called full trust. And there's basically 2 things you get out of that. The first thing is that you can run any piece of native code. You can run a piece of Fortran, C, C++, what have you. And you can run that by just invoking it. And furthermore, you can use a lot more of the .NET stack, because previously the only part of the .NET stack we were exposing was the part that worked with medium trust. So for instance, you can use a lot more of WCF now and various different kinds of transports that WCF supports. The second thing we've done is IIS has support for FastCGI. We've incorporated that in and enabled that. So what you can do is, for any language that you're interested in using, like say PHP, You can take the native binaries, that is the handler for PHP, you can add it to your application package and send it to the cloud. And we've done some extra work with configuration, setting, etc. So it's really easy for you to go to your config and add one line there telling IIS where to find that binary for your PHP runtime, if you will. And then you can go, you can go run PHP or whatever you would choose to use. And I just put PHP up there because it makes for a nice example, because now I can go back to another demo to make that point. So what I'm going to do now is, hopefully at least some of you have Twittered something about how this talk is going. If not, at least there's mine, which I seeded with a 10. And we're going to go back to tweeval.com, which is hosted in our production cloud as we're speaking. And I'm going to access the piece of PHP that is in that service that is actually going to give me the results of my evaluation, right? So let's go do that. So let me try to open that. You can see I've been fooling around with this before. Hey, 9.3, pretty good. All right. Okay, we'll discount the 10 that was up front. Okay, so yeah, let's see. Nice demo. Digging the shoes. Okay, I like that. Okay, that's pretty good. Whoever wrote tweeval.com, he's sitting right over here, so he can stand up and take a bow. I'm the one who said that. Oh, you're the one. Oh, okay. So anyway, so this is running PHP. It's live in production. It's just a tweeval.com. And just to prove the point that it is really PHP, I can, if I take that part out, I should get the PHP info thing for that thing, right, with the usual information about PHP. Okay. So you can go do this today. You can pick up the updated CDP, and we don't actually have the PHP binaries in our SDK for a variety of good reasons, but there's all kinds of samples and help there as to where you can, there's even a pointer there as to where you can pick up the binary, and the steps are pretty straightforward to go get this done. And I know Steve hacked this out last night, so it's pretty straightforward. Okay, back here. So the other thing I wanted to talk about today that is part of this overall experience of using the platform that we're also announcing today is geolocation. And so we've done two things here. The first thing is we have this model that you can think about that is a cloud project. So when you go and use this operating system in the cloud, typically you're going to have some pieces of compute that are running, some services, if you will, that are doing certain things, and then you'll have some data, whether it's blobs or queues or tables, that is also holding data. And we think of the collection of these things as your cloud project, which consists of some storage accounts and some compute services. What we've got today in the cloud is we've got Windows Azure running on data centers in many different places. Obviously, we've been doing that for a while. Microsoft has data centers in many different places around the globe, and now we have production Windows Azure environments running in some of these places. And on the portal, on the dev portal where you go and deploy your services, you'll find a drop-down that lets you select for a particular compute service you want to run or a particular storage account you want to create. You can choose the locale that you want this to be in, US West, US Midwest, for instance. So that's one part of it. The second part of it, which is where the entire framework and holistic view comes in, is that we've got this notion of an affinity group where you can take some compute services you're running and some storage accounts that you've got, and you can put them in a group called an affinity group, and you can tell us all of these things need to be in the same locale because they're talking back and forth a lot, and we want the latency to be really low and we want the bandwidth to be really high, right? And you can do this. And the reason we can do this, again, is because it is an integrated platform, and it's the same deployment management service running in the cloud that is actually managing our storage service and deploying it in different locales and managing our compute services. And when your applications come into us, they come in through the same deployment service, whether you're creating a new storage account or you're creating a new compute service, right? So it gives us this flexibility. So you can create these affinity groups, and really the affinity group does two things. On the one hand, it says, I've got these 15 different things. I'm only going to tell you once that I want this in US West. Do it for all 15. And the other important thing it does for you as a developer is that it gives you some kind of a guarantee that these things are co-located, right? So you're not going to have to worry about the latency across these or the, all right. So we are announcing this thing today, and we have it up and running in our cloud. Actually, we have for some time. But we do want to be a little conservative with this thing and make sure that we don't let you down when it comes out. So we're going to make it available to all external customers through the developer portal in April. And we're currently using this thing internally and have been for a bit. So you should expect this very shortly. Yeah. So that's the other aspect there. Okay, so that was the developer experience part. The next part I want to talk about is the service management. We consider this a key part of our value prop. This is the thing where you enter the name of your service and hit enter, basically. So, and the key attribute of what we've done with service management is that it's automated, right? So there's a lot of things happening under the covers that hopefully you don't have to spend much time thinking about. So the idea here is that when you develop your service, you write your code, whether it's ASP.NET or PHP or what have you. And in addition with your code, you create what we call a service model that you give to us with your code. Okay? I don't want to scare you off by making you think that this is some 20 pages of XML you've got to create somewhere. No, it's not. It's pretty simple. If you look at our SDK today, you'll find it's just a few lines, literally, of XML. So what goes in here? The first thing you do is you tell us your service topology. I've got, sort of like that diagram I showed you earlier. I've got a web front-end role. I want it behind a load balancer. I've got another role for worker role, which is doing some processing. And you tell us the size of this service in terms of instances, not in terms of servers. So you say, I want 10 instances of my front-end role and 3 instances of my back-end role, right? Second thing you do is you tell us what resources you need. Hey, I'm going to need local disk for this, this service, and I think I need 100 gig, or I need 2 gig, or I need 50 gig. You tell us, in your terms, what it means for your service to be healthy. And that way, we know how to alert you when your service is unhealthy. So you might say that, deploy me with 10 instances of my front-end role. If 3 or more of those instances become unavailable, my service is unhealthy. Or you might say, if the CPU load on my server goes beyond 60%, I'm unhealthy. And then we'll fire an alert to you so you know that your service is unhealthy. And we can take corrective actions. We can add more instances, if you will, right? And then there's all the configuration that you always have where you don't want to restart your service if you change some little piece of config. So you put that in as well. Once you've done that, we have all the information we need to go deploy and run your service. So you just hit go, and we've got the resource allocator. We look at the cloud and we say, where do we have a VM available that matches your requirements, your latency requirements? We allocate those resources to you. We put the bits on there. We start the roles. We wire up the load balancers. We do all of that, and then we send you a signal saying, hey, your service is up and running. Here's the IP address for the endpoint you wanted. Go hit it. And then you can go hit it. Right? So we can deploy and run the service in a completely automated fashion. And then really the key interesting part is that once your service is actually up and running, we can go quite a ways to maintain that service for you while it's running as things go bad. If a particular server that a backend role is running on fails, we notice that. We spin up another instance. Maybe it's at a different IP address. We have an API that takes care of that and does a notification. So that you don't really have to go back and do some change in your code because the IP address changed, right? So we can do a bunch of those things for you. And then the final part I want to talk about is storage. And for storage, the key principles that we have are that, number one, we give you this illusion of an infinite pool of storage, if you will, and it's completely scalable from your point of view. Today, your application needs 10 megabytes. Tomorrow, your application needs a terabyte. You shouldn't have to change anything. You shouldn't have to worry about where is this coming from, right? The second part of this is it should be available. Available in many different senses, right? Available in the sense of durable, which is that once you've stored a piece of data, it never goes away, right? No matter what happens to the hardware in the data center. So that's durability. Available in the sense that you should always be able to access it, right? So it's always up. You aren't tied to a particular server, and if that server goes down, your requests start failing or anything like that, right? What we've done here is we've taken, instead of providing everything that everyone could imagine with storage, we've taken a few abstractions that we believe are really crucial to a wide variety of people who build applications in the cloud. And we've really focused on giving you scalable, available versions of those abstractions. So one thing you want to do in a service is you need to store data for people, photos, videos, etc. So you need blobs and file streams, right? The other part is when you're building a service is you've got all the state. You've got metadata about your customers. So you need some form of tables, and you need some form of caching, right? You need simple tables like entities, metadata about people, for instance, right? And then finally, as you build more complex services, you need durable ways of the services communicating with each other. So we've built these durable queues in the cloud, where the way you communicate is you pump a request in the queue, somebody else picks it up, right? You'll notice that some of these things are in white and some of them are in gray. The reason I've done that is the things in white are exposed today. The things in gray are things that we haven't actually exposed out yet. And that's a theme that will recur, and I'll make a point about that again at the end. The emphasis of this storage system very much is on this massive scale, high availability and durability, and again, the ability to spread across the globe. I talked about the geolocation that we've rolled out as part of that overall experience for the developer. A big component of that is the work we've done in the storage system to be able to geolocate, and we'll talk more about that in the storage talk. So we have geolocation today, which means you can pick where you are. We do not have geo-replication today. And let me just clarify that for a second. By geo-replication, I mean that we transparently do something under the covers to replicate your data in multiple data centers. We're not doing that today. We are doing geolocation. So certainly at the application level, you can go implement geo-replication on your end, right? By creating a storage account in one data center and in another data center and sending your storage write request to both places. And that's something that will come down the road from us. A key point I want to make about our storage system, this is the Windows Azure storage system. We do not have a relational database as part of this storage system. So you're not going to get your T-SQL and your joins across tables and that kind of thing from this storage system. This is the file system in the cloud. It's giving you things like simple tables, which are highly scalable partition tables, and things like blobs. Okay? And there's a session, Brad Calder, who actually runs our storage team, is going to give a talk tomorrow, I believe, on this whole storage system, and he'll tell you a lot more about this. So I know this does beg a question from many in the room. Where is that relational database? And we've certainly heard the feedback from everybody. And what I can tell you categorically is that you will get a relational database in the cloud from the Azure Services Platform. And in particular, any app you build on Windows Azure will have access to this relational database. And there's several points I want to make about that. The relational database will be co-located with your app, so you'll get all the benefits of the latency and the bandwidth and the fact that access within the data center should logically be cheaper than external access. You'll get all of that. And you will get the benefit of the existing database programming models, right? So you won't have to go learn something new. You will be able to use the protocols that you're used to using today. Having said that, there are multiple, as you can imagine, for people who use relational database, there's multiple scenarios from the people who, I just want a slice of a database, I don't care who I'm sharing it with or how, but I want to do my SQL queries, down to, I'm an enterprise and I need my whole pool of SQL Server instances of my own, and I want to manage them and administer them in my own way. So there's a range of scenarios, and the work we're doing on the platform is tailored towards the range of scenarios, right? And in particular, there's a talk on the 20th by Nigel Ellis from the SQL Services team that is going to say a lot more about some of these scenarios that we are working on now and how you're going to get this relational database access from the cloud. So that's really something from SQL services. The reason I put a slide in there is I want to stress that if you're running an app on Windows Azure, you're going to have full access to that relational database in the cloud with all the benefits that come from the cloud operating system. Okay. So one slide, I'm putting it all together. There's no bullet points on this slide. I promise you, it's just a picture. I wanted to use this slide to make a point. From the beginning, when we built this Cloud OS and we built our cloud platform, it's been done from the ground up in a way that supports the full spectrum of scenarios of how people want to come to the cloud. At the end of the day, we've got a bunch of servers and we've got VMs running on these servers, right? So there's a lot of different things we can do with these servers and these VMs. And clearly, Microsoft as a company, we target many different scenarios, and that's certainly going to be no different with the cloud. However, a key aspect of what we are doing with this cloud operating system is we believe there's a real opportunity here for the web and for the cloud, which is that if you truly want to build the new services on the cloud that are built for scale and availability, there's a certain way you go about building these services, and I think we've all learned some of these lessons. And what we've tried to do in this platform is really encourage some of those best practices. So I thought I would put up a picture of an example service architecture to make the point about some of these best practices and how our platform is really encouraging these best practices. So this picture should look very familiar to you because this is really no different than that thumbnail service I was showing you earlier, but it's a little more general than that. I've shown you a general two-tier architecture, and I can actually take many different popular websites and web services that are out there in the world today and categorize them this way, that are at pretty high scale. SmugMug's a great example, actually. So here's a web service where I've got a web role that is surfacing some endpoints or some websites. I've got that behind a load balancer. I'm going to scale that arbitrarily. And then it's hitting my cloud storage, which is durable. And then I've got some background processing through a worker role. And they are talking to each other reliably through a queue. So it's all loosely coupled and highly fault tolerant and available. The cloud storage is accessible from within the service and across the internet, so I can debug from the outside, I can hit it from other places, I can hand off URLs to my customers so they can hit things directly. And my web roles and worker roles are free to talk to anything out there in the cloud, so I can interoperate with other services that are out there. All the interfaces for cloud storage, for service management, everything are built on open protocols like REST, so that I can use them in many different ways, right? So now some bullet points to just reiterate what was there. The model is stateless compute and durable storage. There's local disk attached to everything, yes. But we think this is a really good practice for how you build scalable services. You can co-locate everything, which is a key aspect. You try to make things asynchronous and loosely coupled with queues. The platform is open. You can connect to anything. You use open protocols. You can use your own programming environments. And that's really the way to go be agile. The timeline. We launched this thing at PDC last year with our CTP. We've done a refresh today in line with MIX. You can go pick that up, get the updated bits. You can use, with the updated bits, you can run native code, you can use PHP, etc. Just go to azure.com/Windows Azure to get the latest bits. If you're getting up to speed, read all the documentation or go to our forum, which is also linked off there, and you'll find a lot of good blogs and things that people have learned in the last few months playing with this thing. You can sign up for a token for cloud access. I want to say that when we launched at PDC, there was a bit of wait time to get yourself a token to actually get to the cloud. And we've made a lot of progress since then in terms of opening up the cloud. So if you go sign up and get a token, you should have a pretty good expectation that you'll get access to the cloud. And then you can start deploying your services live and hitting them. Today's model is it's a CTP, so it's all free, and there are some quotas to how much you can use. But my experience with the people who've used it so far is that the quota is actually fairly generous. So don't think that you're going to get up there and put a service, and a few days later you're going to hit your quota and you're not going to know what to do. That's not really going to happen. The model you should expect from us as a platform is that we are on an evolutionary path. When we launched at PDC with ASP.NET and Medium Trust, I did see a lot of questions from people, or characterizations from people say, oh, so Microsoft has got this ASP.NET platform in the cloud. No, that's not true. As I said, underneath, we've just got a bunch of servers and VMs, right? But we're going carefully through this evolutionary path, and we're opening up more and more of the facilities in the cloud. Today, we've opened up native code and full trust and all of that. We'll keep doing that. And this is not a packaged software product where, hey, here's V1, and we'll come back to you in 2011 with V2, and it may have some more stuff. You're going to see updates every so often, both in the SDK and in the cloud, and you should expect that through 09 and in the future. We do have a target, though. One specific target that we do have late this year is to make this thing commercially available with a pricing model and all of that, so you can actually start to, you pay, and then a lot of these limits go away, and you can get as much as you want, and you go pay for it. And you should expect, fully expect, that there'll be an array of features that we're not talking about today that you will also get as part of that. Now, that does raise a question of, why am I not standing here today and telling you you're going to get X, Y, and Z at the end of the year? And my simple answer to that is that as a team, we are fairly conservative as a set of engineers. So there's a number of things we have in the platform today, and we're working on getting them ready for prime time and ironing out the kinks and making sure that we won't let you down when those things come out. And we'll keep turning them out, and you'll see them as they come along. But we're really not in the game of standing up here today and talking about all this stuff you're going to get when it's not actually available to you to go play with. And we do want to be careful about that. So what is Windows Azure? Yet again, to put this slide up, it's an operating system for the cloud. Hopefully, I've gone at least a little way to clarifying what those terms mean for us. It's meant for utility computing. It does 4 things, right? It lets you write your apps, host your apps, manage them, and then store your data. That's really what it's about. So time to go back to look at the results. And I've put this demo in intentionally to make one more small point. Okay, this time, instead of going to index.php ? Whatever, I'm just going to do that, a more friendly link. Right? Oh, it went up from 9.3 to 9.4. Somebody did good. Okay, so the point I wanted to make was that it's an evolutionary platform, right? And we bring more things in. So one of the things we did for this refresh was we enabled some new things from IIS, such as the URL rewrite module, which allowed Steve in his app to say that, index.php ? Tag equal to DAS. This is a pretty name for that, and it should get redirected to that, right? So we've got that feature in as well that you can play with in the cloud. Okay. And finally, I guess this concludes the spiel that I was going to give you, but I want to remind you again, before you leave, we do have some time for Q&A, and what you need to do is just get behind one of those microphones, and I'll be happy to answer any questions you have. But thank you very much for your time, and yeah, thank you. Yeah, and if you have questions, could you get back to the microphone, please? One more point I do want to make before too many people leave. You do have these evaluation sheets in your bags, and if you can take a minute to fill your sheet and hand it to the person at the door before you walk out, that would be great. Okay, let me go back. This slide? Yes, sir. Okay. Yeah, could you?
My department is going full tilt on Amazon AWS development under Windows Server 2003. Is there any reason that they should stop doing development on that and start working with Windows Azure? Is there anything in Windows Azure that we can't get right now through AWS?
Okay, so I don't want to comment specifically on what Amazon is and isn't doing. Clearly, they're out there. I'll put it this way, right? I think if I'm a developer building an application, and I do play with Windows, if I do use Windows Azure, of course you have Windows Server running on the VM you're actually on. But I think you'll find a lot of benefits to actually running on Windows Azure, because the whole experience of developing your application and deploying it and managing it, I think you'll find that it's fairly friendly. And yeah.
Okay. Thank you.
Sure. Any other questions? So does that mean I get a 10 from everyone, or does that mean I get a 0 from everyone? I don't know, but yeah. Could you use a microphone, please? Thanks. Are there people who want to ask but are not doing it because they don't want to walk all the way to a microphone? We can discard the rule then. So, yeah.
So there's a lot of platform as a service that use web-based tools only to develop cloud applications. Do you have any plans to use technologies like Silverlight to provide this kind of web-based tools, or do you think you'll pretty much remain Visual Studio-based or Eclipse-based?
Oh, I'm trying to think. I think there's a couple different aspects to what you were asking. One thing is that there's no reason why an app, if you're building an app that has a client-side component and a server-side component, right? There's no reason why the client-side thing couldn't be Silverlight, right? Right. Right. So that's an interesting question, and I think we do have some sessions at MIX where the Visual Studio team is going to talk a lot more about their plan for development tools, right? I think it's a fair question, right? I will say this, that the SDK itself that we've built is built with an open interface, right? So presumably you can go down that path, right? You can build browser-based development environments, et cetera, for this thing. Now, whether we as a company specifically do something along those lines is a separate question. That is really not my domain to answer.
Hi there. So we have an application which we use Akamai fairly heavily for our CDN needs for it.
Yeah.
And largely that's how we've handled scaling out, but that has limitations when it comes to user customizations and things like that. So where would you see Azure fitting in kind of the tiers of CDN to application server? Or is the price point for the bandwidth distribution going to be competitive to something like an Akamai for flat file storage and what have you?
Right. So I'll answer that question for you in two parts, right? One is when we designed our storage system, right, we've definitely designed it in a way that it is, let me say, ready for CDNs, right? And it should be fairly straightforward to hook up, any CDN to our storage system. We've got URLs for various things, right, to hit every one of your items of data. And I think the other part of the question was, what might we as Microsoft be doing or not doing? Is CDN part of our platform, right? And again, clearly we're aware of CDN, right? And it's something we think about all the time. And I think it's part of the overall experience of the app hitting the user. So that's definitely something that we are thinking about all the time. But I don't have anything in particular to announce or talk about.
No. Yeah.
But the storage system is definitely designed in a way that if you need to use a CDN to get better connection with the people who are hitting your service or hitting your data, you can go do that with the system.
So then I guess just your thoughts around, so we use the CDN to cache the actual page output as well, not just media delivery. And if you think, from your experience, whether it makes sense then just to scale out the Azure system so you're actually generating and delivering those pages for real from the cloud,
yes.
Or whether a CDN would still be required on top of that for price point performance issues.
Sure. I think the fact that we are geolocated and that you would basically be able to host your pages in many different data centers in different locales to begin with is probably going to help you to some extent with that. I don't know specifically if you would need improved latency beyond that, for instance. Right?
Sure, that becomes not so much a latency issue as a time for page generation issue.
Right.
And so whether or not you would scale your cloud out to have
I understand
300 servers that are load balanced, or whether it would
right.
still make sense to have a CDN in front of it.
Right. Yeah. I understand when you're going, and I wish I could satisfy you by giving you a more concrete answer, but I really don't know how to, because I think you have to just see, it depends on what that app is doing, how much compute is actually going into generating those pages, for instance, right? Would go some way into determining that. So I think it's something that what I would recommend is go, use Windows Azure and put the app up, right? Scale it up and see how it goes. And we certainly do have limits in the portal as to how many instances you can get, but if you, for your experimentation now, you want more instances, that's very possible, and you just ping us, and we can give you access to more scale, and you can try that out and see, run a bunch of instances and see what performance you're getting.
And secondarily, with the availability of the relational databases coming or present, would you be able to do something along the lines of replicate a local or in-house database out to the database on the cloud? Is there anything that would stop that from happening?
Yeah, that's a good question, and I think that should be, I'm not the database person, and what I would recommend is you go to Nigel Ellis's talk and ask him that question there. From what I understand, that should be possible. Now, I do want to clarify one thing, that the things I mentioned, like the full trust and the native code and geo, etc., those are announcements where you're getting those things now. The relational database announcement, that is not something you're getting today. There is no relational database service you can hit today, and Nigel will talk more about the roadmap for when that is coming, right?
Thanks.
Sure.
If a large corporation like HP or whomever wanted to roll out their own cloud, is Azure a technology that they could utilize on their own, or is the Azure a single instance for Microsoft?
I see. Okay. That's an interesting question. Let me put it this way. I'll answer your question in two parts. Windows Azure today is a single instance cloud. Okay? But once again, I'll repeat that at the end of the day, we have a sea of servers in many different places, and we're running VMs on these things, right? So it really doesn't preclude the scenarios that you're alluding to. But as of today, Windows Azure is a single instance cloud, and you come and deploy applications on it, right? Yeah. And there's even with today's single instance, you come and run an application, your application can do many different things, right? So it's already the case that you can imagine building things on top of Windows Azure that expose a certain environment to your set of customers, right? So you've already got that sort of how should I say? There's already a layering model in place where for a particular scenario, you can create a customized environment, if you will, just by building an app that runs on Windows Azure. Yeah.
There's a couple capabilities that I've not seen yet on a Azure roadmap, and for instance, things like master data management or kind of rules capability would be great candidate for cloud applications, because you can think of some master data being reusable by many applications as well as rules, and including some smart rules like validating an address, or having some rules related to a legal piece of legislation and whatnot. Do you have plans for master data management, business rules engine as a capability of Azure?
Yeah, I think that's a great question. That's actually great feedback. And I mean, I don't have anything in particular to share today, but what I'll do is I'll just take that feedback back to the team. I think that I can see that being of real value. I would say one way of thinking about it is that when you get to that level of stuff, one way of thinking about those things that are missing today is the way we've kind of approached it is, let's make sure we have the primitives and the facilities in the platform so that even if we don't roll out those higher level things today, a third party can certainly go do that, right? And we certainly hope there'll be a rich ecosystem, right? I mean, we have a tradition of being a platform company. We've done more than one platform that has been reasonably successful. And I think one big reason for that is because an ecosystem has built, right? And the more we open up and foster that ecosystem, the better. So I'll give you an example, right? I'll give you a couple of examples off the top of my head. One related to what you said. We have this concept of storage accounts with storage credentials, right? And the way people go create Windows Azure projects is you can do as many different compute apps as you want. that have their own set of credentials for users and things. And then you can create different storage accounts, and each has its own credentials, right? So what you can do is you can already start siloing things. And somebody can build a setup on top of that for different levels of sharing, right? I've got an app, and there's part of my data that I want another vendor to play with, part of my data that I don't, right? And I can use these different credentials to split that data and do that kind of thing. Another example I would give off the top of my head is that the SDK has open interfaces, right? So certainly we've done integration with Visual Studio. You can imagine building a whole host of different kinds of tools, including like Silverlight-based or browser-based or whatever, to help people manage and deploy their applications, right? So certainly over time we may roll out some of those things, but I think we really want to enable all the primitives so that there's a rich ecosystem of people who add that kind of stuff. All right. Okay, well, thank you again.